Welcome to the ACS Learning Center. Today we're going to do a review of the cleaning chemistry in laundry. Let's start out our conversation by talking about water. Water, it is the best cleaning agent around. It is the most used of any cleaning solvent that we have. Things we need to know about water. It's unique. It has some unusual characteristics to it. It can take on different forms. Water expands when it freezes, and that's unusual. Most substances will get smaller or it contracts. When water freezes, it actually becomes lighter as a solid than it does as a liquid. This is why your ice floats. It is the closest thing that we have to a universal solvent of any liquid. Water can also cause devastation in our dishwashing and laundry operations. To better understand that, we're going to take a look at the water hardness, pH of the water, and any iron content that water may have. Let's take a look at the difference between hard water and soft water. The big difference here is that hard water contains calcium and magnesium salts. Soft water, by comparison, has little to no calcium or magnesium. As the hardness of the water increases, it actually becomes more difficult for us to remove soils. As the hard water increases, it also causes laundry detergents and laundry chemicals to be less effective. It's important that we monitor the water hardness. This should be done on a regular basis within your accounts. Some of the effects that hard water has in the laundry operation. Your fabrics can become gray. They can lose brightness. Colors can fade. They generally can look unclean and look dingy. When we're looking at soft water versus hard water, one of the things that you will notice in a soft water operation, you will have more suds in the wash wheel. In hard water operations, it has very little suds. The detergent, the surfactants in the detergent can actually produce them very well. So again, just to recover this, water hardness is defined as the amount of calcium and magnesium present in the water. And then most people understand water hardness as in grains per gallon. But when we do titrations, our titrations are always in parts per million, and there's a calculation to convert that into grains per gallon. In most of our laundry operations, the detergents that we use, the builders that are within it, we can operate fairly comfortably all the way up to a hard water level. Once we start getting into a very hard water level at 10.5 grains per gallon and higher, customer actually needs some assistance with this. So there's two methods that a customer can overcome hard water effects. One is we recommend a water softening system. Second, the use of phosphates or other sequestering agents. Again, sequestering agents or phosphates, when these are injected into the chemistry or into the water of a laundry, they actually surround minerals, creates them inactive, and then allows our detergent, our bleaches, and other ingredients to actually perform as we're expected. A lot of our autochloride products already has sequestering agents built into it to overcome this. And again, as we talked about a second ago, when we start getting above 7 to 10 grains or above hard water level, customers still going to need a water softener. Next, take a look at the pH scale. So pH is basically just a measurement of acidity or alkalinity in a solution. That measurement is generally between 0 and 14. 7 being neutral, 0 means it's on the acidic side, 14 means it's on the alkalinity side. So when we're looking at how the pH affects our wash quality, depending on the type of soils that we're wanting to wash out, depends on whether our washing solution needs to be on a higher pH scale or a lower pH scale. If we're trying to remove rust, metal oxides that are in there, or even tanning type stains. Tanning type stains would be like coffee and teas. We would want a lower pH. To achieve a lower pH within the wash cycle, we have to be adding sour. Sour is an acid that lowers the pH. On the other hand, if we're trying to clean some really heavily soiled item, greasy items, it's particular in food and grease, then we need to add an alkali in there because we want to raise the pH scale. Other products like wool and silk, we need to keep it neutral. Neutral being around 7 right there. Anything on the acidic side or alkaline side on the raising their pH can actually damage some of these type of fabrics. Iron. Iron in the water can actually be coming from the incoming water supply. It can be from natural sources. We have many areas around our company that actually has iron in the water from wherever the water company gets their water from. Iron can also be added into the water either from old iron pipes or old water heaters. As little as 0.1 parts per million of iron can actually cause stains and discoloring of our linen. Anytime that we would use a chlorine bleach with iron in the water has some really negative effects to it. In the case that we use chlorine for our laundry process and we have iron in the water, we need to change products. If there's iron in the water, we need to change from a chlorine bleach to an oxygen bleach. It will perform much better and help remove some of the soils and stains in that environment. Next, let's take a look at the principles of cleaning. Again, principles of cleaning, whether we're in warewashing or in laundry, are basically the same. The two big differences is that in warewashing, principles of cleaning are connected to hard surfaces. In laundry, we're connecting to linen or fabric. So there's 4 basic principles to the cleaning: time, temperature, chemical, and mechanical action. Again, when this was first started or first created, they created the wash pie. The wash pie divided these 4 products, time, temperature, chemical, and mechanical action, into 4 equal parts. To get good results for cleaning chemistry, all 4 of these has to have an equal part to it. Now, as time went on, we've changed this. We've come up with the complete wash pie. The complete wash pie adds a 5th element into the wash pie: procedures. As we learned over the years, time, temperature, chemical, mechanical actions all do a great job. But if the customer has poor procedures, then we still have a very bad balance for cleaning results. When we look at all 5 of these principles, again, each one has to have an equal part. When one or more of these parts gets affected, and in this case we're showing you an affection of temperature, 110 degrees. This is pretty common in our nursing homes and hotels and motels. When the temperature drops, we have to be able to increase one or more of the other principles to offset the difference. That wash pie has to stay equal, round. If it becomes egg-shaped, you're going to get poor results. If we have low temperature, we may have to increase time to compensate, or we have to increase chemistry to compensate, or a combination of it. One of these principles there is virtually no compensation for. If we lose the mechanical action by a customer overloading or underloading, there is virtually no way to replace that. This is where it's imperative that procedures are followed through with our customers. Now let's take a look at each one of these separately. So time is the amount of time it takes for the total operation from the start of a wash formula to the end. It is also refers to the amount of time it takes for each step, whether it's a wash step, a bleach step, rinse step, sour step. Each one of these takes time to accomplish. There has to be a balance between the productivity demands of the laundry or the customer and the time it takes to get good results. In a lot of cases, you may have customers that wants to pressure you that says, hey, we need to shorten the formulas. It's taking too long to clean. Our job is to educate the customer in receiving quality results that it takes time to do this. And anything that we're going to reduce the time could actually be causing more stains that they're going to have to go back and rewash, which will be even more time for them. So we need to educate the customer in the correct procedures. Temperature, another big component part of the wash process. Again, recommended in a laundry, we always recommend between 140 to 155 degrees. Most washing machines has the ability to put in hot water, cold water, or warm water, combination of the hot and cold. These temperatures can actually vary greatly between one account to another. Nursing home and hotels, generally 110 to 120 degrees, to where you have other accounts that may as much as 180 degrees. The heat or the temperature of the water can actually speed up the chemical reaction of our detergents and help remove soils quicker. The temperature also affects the type of soils. If we have greasy food soils, hotter the temperature, the easier it is to wash out. Makeup stains, which is a huge problem in hotels and motels. It requires 150 degrees to start melting makeups. Again, chemistry that we use actually can go in and start breaking it down at lower temperatures. One of the things we wanted you to keep in mind, though, that when we're looking at a drop in temperature, when we start dropping below 115 degrees Fahrenheit, you start reducing approximately 15% in chemical reaction. That's a big difference. And again, when we're choosing the right temperatures or we're washing in the right temperatures, we always got to look at the type of fabric. You wouldn't want to wash silks in 180 degrees. What's the construction of the fabric? Is there any colors? And again, high temperatures can actually fade out colors. Chemical action. This is the process of where we're adding laundry products into the washer. Again, we're adding laundry products to the water to enhance the water's ability to remove the soils and also help fight off some of the stains. Most laundries will use anywhere from 3 to 5 products, depending on the type of washer, type of linen, the amount and type of soils that we're washing. Mechanical action. Mechanical action is the drum of the washer turning. Generally, it will go in two directions. It'll go forward, it'll stop, it'll turn, it'll go backwards. That's in there. Mechanical action is the movement of the linen to help remove it. Go back to the beginning days when they used to beat their clothes on the rocks or use a scrub board. Again, there has to be mechanical action to assist the detergency in removing soils. Again, without any mechanical action, cleaning is not going to take place. When the mechanical action is impacted, we're going to have to increase time, temperature, chemicals, and again, it cannot make up fully for the loss of performance of overloaded washers. Again, mechanical action is driven by two different things: water levels and the washer loading. So here we're just going to take a view of the wash wheel from the outside. Very simple view that's in there. So one of the things that we take a look at is we look at the washer blades. This is what you'll find inside of the wash wheel. This is what's actually moving the linen around. When we're looking at water levels, high water level generally is just above the glass. Low water level is usually just below the glass. This is going to vary slightly based on the make and model of the washers and the size of the washing machine. Loading becomes a very critical factor. When we're doing a visual inspection and working with your customers, they should not be loading it in where they're just stuffing it in. They're using their feet, their shoulders, their arms, and they're just cramming as much as they can in there. That's not how washers work. So when they're loading it in, they should be loading it up to about 4 inches from the top, or about a fist width from the top of the fin inside of the drum. Again, this will give them enough clearance so when the linen gets wet and compresses, it gives good mechanical action. Another method for loading is weighing the linen. Now, most of your customers won't have scales, but one of the best methods is weigh the linens for the washer size. Another one is going to be watch the mechanical action. So after they load the linen, they start the washer and all the linen gets wet and saturated. We start looking at the linen turning. Again, you should be looking at a fall rate anywhere between 12 and 3 o'clock or 12 and 9 o'clock. So again, as we're looking at this washer right here, you can see we're about 12 o'clock to around 4 or 5 o'clock. What we're looking at here is an underloaded washer. It means we're wasting time, chemical, water, energy. They could be loading more in here to produce more linen at the end of the day. Here's the opposite end of the spectrum. This washer is overloaded. Here we're getting virtually no mechanical action. We can just watch the same linen going around in a circle. And again, we need that mechanical action. We need that abrasion of the linen, rub it against each other to help remove the soils. This is an overloaded washer. Here we're looking at a washer that's properly loaded. We're getting good mechanical action. There's good distribution. And as the washer goes from forward to reverse, the linen is getting mixed up. Water, detergency, alkalinity, or bleaches, all getting mixed through the washer extremely well. This will give quality results. The last thing we're going to take a look at in the principles of cleaning is the procedures. And again, if the customer has poor procedures, then we're going to have poor quality and results. There are many reasons why a washer can become unbalanced in the variables of an operation. One is improperly maintained dispensers. Again, this is our part right here. If we're not maintaining the dispensers, we're not making sure that our squeeze tubes are good, our pickup lines are working, our flush solenoids are coming on, and we're flushing the chemicals in, that's on our part. The other is the maintenance of the washers. Does it have leaking drain valves? Does it have leaking fill valves? Is it operating correctly? And again, all this can affect the results and quality of the linen. Other things could be procedures. Are they shortening the cycle? Is the customer learn how to advance the cycles and we're skipping over steps? Are they using the right formulas? You'll find customers that will find the shortest formula and they'll wash everything on. And then we look at their loading. Are they overloading or underloading? And in most cases, customers will overload the washers. To learn more about the principles of cleaning, talk to your manager, regional manager, or vice president, or contact the training center for more information.